Okay, so we're going to be going over the solution to the 26th problem in the Grind 75. This one is called Insert Interval. We are given an array called intervals with intervals in them, where an interval is a two-element array with a start value and an end value. This array has intervals that are non-overlapping, and they are sorted in ascending order by their start value. We're going to be given an array called new interval, and we're going to have to insert it into this intervals array and merge any intervals if there are any overlap, so that the original quality of it not overlapping is maintained. So let's look at a concrete example. We're going to switch over to Paint really quick. So we can think of our original intervals list, the input list, as this middle row of intervals. They're sorted in ascending order by their starting value, and they are not overlapping. An example of new interval, or the interval that we'll want to insert into this list, would be that one, or would be this one. So basically there are three different types of places that are that new intervals can be in relation to the current interval that we are on. So what we are going to do to solve this problem is iterate through our intervals list. So if we start here, we'll see the first condition, which is that the last value of our current interval is less than the first value of new interval. So that means they're not touching, and we can safely add this value. Now the other case, which is similar to that, is now after having gone through this and merged these properly, if this is our current interval and we see that its first value is greater than our merged interval's last value, then we know we can safely add the merged interval finally, because we've reached a gap, a spot where there's no more merging necessary. And then what we would actually do is set our merged or new interval equal to this, and then just kind of compare that to every interval that happens afterwards. Because of that, we will have to return new interval at the very end, but we'll see that that actually works in our favor. So let's go over the solution really quick, and then we'll also jump back to Paint once we get to certain spots in the implementation. So we're going to switch over. Okay, so they want us to return intervals, but we won't be able to insert lists and merge existing lists with a regular Java array because those are immutable. So what we're going to do is create a linked list of intervals, and we're going to call that results. We're just going to set it to a new linked list of intervals, like so. And then we're going to iterate over intervals, the input array, by saying for each interval in intervals, we are going to check for the three cases. So the first one was, I'm going to switch back to Paint. If our current interval's last value is smaller than new interval's first value. This means that our current interval is completely before new interval, so we can safely add it. So let's just switch over. So if interval's last value is less than new interval's first value, then we can safely add interval, the current interval that we are on. Okay, then we have the other condition, which is if we have gotten to the end and our current interval's first value is greater than the merged interval's last value, then we're completely away from any merging that needs to happen. So we can also safely add it, but we are actually going to we're going to add it to result. So result.add new interval actually. We're going to add new interval because we are safely away from any merging, so any merging that has happened can finally be inserted into our results list. So we're going to add it, and then we're going to set new interval equal to our current interval. And we know that our current interval should be added, but in this, if this is the case, it won't get added inside of this block right here. It's only going to get added until we finish the loop. But if we have finished the loop, like in this case right here, where this is the very last, oh, that was messy. If this interval is the very last one in our original intervals array, then we're going to have to make sure to add it. So we're going to do this at the end right here. We're going to say results.add new interval. And what this also does for us actually is adds our new interval if our original intervals list is 0, because intervals can be of size 0, but we will always have new interval of size 2, meaning we will always have a value for a new interval. So that will automatically add it and then return that, and that will be fine. And else, let's see why this is the only thing that we have to do. So switching back to Paint, if we are at a case like this one right here, and we know that our last value does not come before new interval's first value, and our first value does not come after new interval's last value, then we know we must be overlapping in some way, because this value has to be here at the farthest, and then it can be anywhere over here. And similarly, this value can be here at the farthest and must be all the way over here. If 1 were to be all the way over here, then 3 would also have to be all the way over here. And similarly, you know, if 3 were all the way over here, then 1 would also have to be all the way over there. So there is some overlap in some way. And the way that we handle overlaps of any kind is to simply set new intervals first value or starting value to the minimum between the overlapping intervals, and set new intervals second value or ending value to the maximum of the two intervals values. So let's just write that out. So because we know we must have an overlap of some kind, what we're going to do is set new intervals initial value or start value equal to the maximum of our current interval start value and new intervals start value. Similarly, we're going to set the end value of new interval equal to the, actually, this should be the minimum. So we get the farthest left start, and then we want the farthest right end. This can be interval index 1, new interval, also at index 1. Okay, so that's going to be that. Again, new interval will eventually be added once we find the interval that is not overlapping with everything that we've been merging. And then we can add new interval, and then we'll set new interval equal to that, and we sort of already went over when that would get added. It would get added right here. Okay, so that is the logic of this problem. Now all we have to do is return the original intervals object, because that's what they're asking for. We want to return intervals. But right now it's in this linked list. So luckily collections in Java have this nice method where we can just take our this is linked list is a class that implements the list interface, and the list interface implements or extends the collections interface. I believe that's right. Definitely double check me on that. But we're going to have to set basically collections have this nice method called toArray, where we can set it to a new integer array of result.size. That's going to represent all of the intervals, and then this is going to represent the intervals size. Intervals, yeah, specific size. Then all we can do, or all we have to do, is return intervals as they ask. So let's make sure there's no syntactical issues. Okay, yes, I forgot to put the condition. So this is if we're at the end. So if the current interval we are on, its start value is greater than new interval's last value. So we've, exceeded, we've gone past. And that should be it. Let's see, result.add, did I spell that wrong? Interval. New interval. Yeah. Okay, maybe I should probably check all of the, okay, yeah, that works. All right, and that has been the solution to the 26th problem in the grind 75. This has been insert interval.